Alright, so this is the final exam review of the module Application of Newton's Laws. And what I've decided to do for this module, since it was a low test average, was I actually went through and pulled the most multiple choice test questions in every category. So that way we can go over and talk about some of those things that maybe you got wrong on the test, or maybe you got another problem that was similar to the test. So anyways, no matter what, it's going to benefit you for the final exam. So again, this was the most missed multiple choice questions for every subsection in the application of Newton's laws. Alright, the first one was a normal force calculation, and the problem states that a 5.00 kilogram box on an elevator accelerates downward at 1.00 meters per second squared. What is the normal force of the box? Alright, so we have to first think about the formula that we're going to use, and then also think about a diagram. I always like to draw things when I'm not confident with what's going on. So here's an elevator that I just drew, and there is a box on this elevator weighing 5.00 kilogram, and the elevator is accelerating downward at 1.00 meters per second squared. It's asking us what the normal force would be. So we know this formula, so normal minus weight equals mass times acceleration. Basically, we're just going to rewrite it. So we're going to rewrite normal force equals weight plus mass times gravity. We know that in weight equals mass times acceleration. So we can replace the W with mass times acceleration to get this formula right here. And then we plug in what we know. So we have that 5 kilogram mass box accelerating at negative 1.00 because it's going down, plus mass, again, 5, times gravity, 9.8. We add that into the calculator to find our normal force, and that would be 44 newtons. The next one is the most missed question over friction, and it was asking you to calculate something from that friction formula, the fun formula, right? So it says, what force would be required to pull a 565 Newton woman across the floor if the coefficient of friction between her shoes and the floor was 0.75? So we have that friction equals that coefficient times that normal force. So we know that the normal force equals the weight, 565, because remember, it's pushing down same way it's pushing back up. And so then we add in what we know to the frictional formula. The coefficient is 0.75 times 565, that normal force, and we should get 420 newtons for the frictional force. Alright, this is the most missed question over tension, and it was asking you to calculate that tension or something out of it. So it says, what is the tension on a rope allowing a 7.5 kilogram box to accelerate downward at 4.00 meters second? So again, let's draw a diagram here. We have the box that is 7.5 kilograms, and we have the tension on a wire to accelerate downwards at 4.00 meters per second squared. Let's look at the formula here. Tension minus the weight, right? Because the tension is holding up the weight that's being pulled down. And so then we can substitute things that we know from the problem with other formulas that we know. Again, weight equals mass times acceleration. So we add that in. So we can rewrite the formula down here, including that mass times acceleration, and then we can solve for tension. So we have 7.5, which is that mass, times acceleration. Remember, it's going downward, so that's why we added negative. A lot of people forget to do that. I think that's why a lot of people got this problem wrong. 7.5, which is the mass, times gravity again, 9.8. Plug that all into our calculator. We should get 43.5 newtons for the tension on the wire. All right, this one is dealing with tension and spring. It says a spring with a spring constant of 3.00 newtons/meters applies a force of 10.0 newtons when it is compressed. How much was the spring compressed? Remember that there is a special force formula for spring that you can see here. I'll keep doing that. Apologize. So we are going to basically just rewrite the formula, asking for how much that spring is compressed. We know those two variables. We plug into the formula, 10 minus divided by 3, and we should get 3.33 meters. That's going to be the distance that the spring, think about that, is compressed. That's my spring drawing. All right, system calculations. This one says box A has a mass of 40.0 kilograms and box B has a mass of 25.0 kilograms. Box B is pulled to the right with a force of 240 newtons across a frictionless surface. If the acceleration of the system is 3.69 meters per second squared, what is the tension T on box B? So let's look at this free body diagram right here. We have box A and box B. It's kind of blurry. So again, we have that normal force pulling up, the weight pulling down, and those little A's just mean that it's for box A. And then we also have tension pulling in this direction. This box has tension pulling back, a force being pulled forward, and also normal and weight. Alright, so now let's think about the formula that we have, and again it's the same formula that we're using. These little B's and little A's sometimes throw off students, but remember it's just signifying that it's box B. So we rewrite the formula to solve for T, and we get T equals the force minus the mass of box B times acceleration. We plug in what we know, 240 minus 25 times 3.69. And again, this is all given us in the problem. We have 240, 25, and 3.69. It says if the acceleration of the system is 3.69 meters per second squared, what is the tension box on B? So we're really not even focusing on anything on A right now. If we plug in that calculation, we should get 148 newtons. All right, here is an example on slope components. That was a commonly missed question, again, on the test and the multiple choice part. It says a box is at rest on a slope with an angle of 30 degrees to the horizontal. If the mass of the box is 20.0 kilograms, what is the parallel component of the weight? So again, let's think about the box here, 20 kilograms. And again, we have that parallel component. I'm trying to draw straight lines, and it just is harder than it looks. Parallel to the surface. So we know that the parallel formula is mass times the gravity, because the mass and the gravity is pulling down here, or the weight, sine the angle. So the angle would be what is given in the problem, 30 degrees. So then all we have to do is plug in what we know. 20 times 9.8 sine 30. And that's going to give us the force, or the weight, because remember F equals weight, 98.0 newtons. All right, this was the most missed question for centrifugal force and velocity. It states an 85.0 kilogram man and a 65.0 kilogram woman are riding a Ferris wheel with a radius of 20.0 meters. What is the Ferris wheel's tangential velocity if the net centrifugal force on the woman is 115 newtons? All right, so think about the two formulas that we know about centrifugal force. We talked about them actually earlier in the one-dimensional kinematic unit as well. I'm sorry, the two-dimensional kinematic unit. So we rewrite the formula to solve for V. I think a lot of students probably got this wrong because of just simple algebraic mistakes. Remember that you're going to take the square root of this entire side. So that's the last thing that you should do in your calculator. So anyways, we're going to plug in what we know. So we're going to take the square root of 115 times 20 and divide that by 65. So you should put in your calculator 115 times 20 and then hit equals, divide that by 65, hit equals, then find the square root of that number. And if you've done it correctly, you should get 5.95 meters per second. And again, this was velocity. Gravitational force. It says, what is the force of gravity between two 70.0 kilogram masses that are separated by 2.5 meters? So think about the formula for the gravitational force and the constant. Remember that we have that G. We just did a virtual lab over it. We plug in what we know. So we have two masses that are 70. So that's where we're getting the two 70s in there. And divide that by 2.5 squared, which is the radius, also given to us in the problem. When we plug that into our calculator, we should get 5.23 times 10 to the negative 8th. If you need a refresher on how to multiply scientific notation, make sure you go and review that first module, Math of Physics. That is it for the application of Newton's law. So now I am going to open up for any questions that you guys have for me.